Hello friends, welcome to Akulmach Live and I am Chandrakant. Yesterday we talked about Tesla deciding to allow other electric vehicles from other manufacturers to come and use their charge points and charge their vehicles. So I think there is a little bit of standardization which is going to happen. That means a plug which will be standard across all EVs. And today we are talking about the next leap in battery or energy storage technology. And for this discussion, I will be joined by a very special guest joining us from UK. Before we start the discussion, I have to tell you that there is this QR code using which you can get connected with us instantly. All you have to do is point your mobile phone camera on this QR code and you will be connected with us. So friends, don't go anywhere. I'll be joining back with my friends in a moment. Welcome back, friends. And today we have Mr. Neval Gunt as our guest. He's joining us from UK, and we have a very interesting subject to discuss, and it's about the new advancements in electric vehicle or electric propulsion or electricity store and use technology. So, Neval, welcome to the show. How are you doing today?
Good morning, CK. Good morning, everybody. I'm doing really well, actually. We're in the summer in the UK. You wouldn't believe it with the rain that's falling outside, but or maybe that's what people expect of the UK. But yes, doing very well. Looking forward to this discussion today, which follows on from our discussion about charging, electric charging vehicles, and the way that we're looking at, or the way that Tesla is now looking at being less of a monopoly and more in the collaborative arena, let's say, by allowing lots of people, anyone, to plug into their charging stations using their universal plugs, which is great. It's good news. And today we're going to talk about something that will enhance that arena. So as we all know, one of the biggest problems that we have is storing energy in batteries. And then actually physically getting to the point where, I mean, where are all these, Tesla units going to get their energy from? So look, that's the expansive discussion we're going to have today. And in essence, CK, I suppose we're going to be talking about capacitors, aren't we?
Absolutely, Neval. In fact, battery development has reached its peak. And this is as much juice as we can get is already coming out from alkaline batteries today. So what is the way out? Because with the normal batteries, even high output batteries can take you up to only 200 miles with such a heavy weight. Because if you increase the batteries in your vehicle or your aircraft, it will never take off. So the challenge really is the energy density. And the solution that we can think of is storing the energy and have an instant burst out into the battery whenever it is needed. And then the electric vehicle will become practical solution, and then it can replace the conventional internal combustion engines. Why? Because that is the second problem. Because yesterday we talked about charge points, but then charging will take minimum 30 minutes. Even if you go for a fast charge, it will take minimum 30 minutes, and that is not good.
Yeah, it's true, and we've seen a lot of advancements in the battery arena. I mean, just take your smartphone. I mean, when those smartphones came out, the battery would die within a couple of hours, because it was being used. And then all the advice was, well, make sure that you completely deplete the battery before you recharge it. And several years later, iPhones in particular have got a very long battery life, and these things don't overheat. And even if you do keep them on almost a permanent charge, it seems that their life of the battery is still quite long. I mean, it's probably longer than you would want to keep the smartphone. So we're making big inroads in a small way in some respects, because remember, your smartphone is quite small compared to the type of batteries that we're going to be using in electric vehicles. But we need to be thinking smarter. We need to be thinking differently as to how we get the charge into the battery. How quickly can we put the charge into the battery without the battery being disadvantaged? You know, in other words, without reducing the life of current batteries. So we've got some fantastic engineers around the world all looking at this arena. And naturally, they're looking at the solar power conversion into these batteries. So I can imagine, as we talked the other day, about all of these, pop-up type energy transfer units that Tesla are going to be putting dotted around India and probably everywhere else around the world. How are they going to get the energy? And it's going to come from solar power, because they're not going to be, sitting next to a McDonald's or a KFC or what have you. Well, they probably are as well, but they're going to be in other areas. That hasn't easily got an electricity source. So we're really looking, I think, CK, at the transfer of energy between solar power, of which India is fortunate because the sun shines incredibly well in India, as opposed to Iceland, which doesn't get so many hours in the day, and the capacitor arena. So the advancement in capacitors, and we've seen that in Formula One, where they use the ERS system, energy recovery system. And I think some of the, and this is another arena where F1, Formula One, it's the motor racing arena of the world. Grand Prix circuits around the world. I'm looking forward to the first one in India, by the way. We need to have one there. But all of these advancing arenas where they're pushing the envelope. So where the likes of Bezos and Elon Musk and Richard Branson are pushing the envelope into the space race, some of those technologies are coming back to be utilized literally on terra firma. What can we do here? How can we improve what we're doing here? And I see a tremendous improvement in capacitors recently. And I think we're probably going to paradigm shift in the capacitor arena shortly. What do you think?
Well, Neville, actually, capacitor, for the just to explain a little bit for the benefit of our viewers, is a very simple device. It has no moving parts. It has no liquid in it, unlike a battery. It has two metal sheets, and they are blocked by a dielectric. So when we say dielectric, it is nothing but an insulator, like a plastic or something like that. Mostly ceramic is used as a dielectric in the commercial capacitor production. And today, so this is not something new. It has been there for almost 150 years. But what is important in a capacitor, it has a capacity to charge instantly within a second and discharge also. So if you look at our watches, they move precisely after 1 second, and that is being done because there is a capacitor inside the watch which releases the current after each second, which will rotate the mechanism of the watch. So what changes now in the capacitor technology is that scientists are working on charging instantly and discharging slowly, so that the capacitor can get charged from a charging station as soon as you plug in. It is almost like filling petrol in your car. You go to the petrol station, pay the money, get your car top up, and on your way. So similarly, you swipe your card on a charging station. Since you have a capacitor, a large capacitor in your car, plug in, it will get charged instantly. It will have 1-2 kilowatts of power, and then this capacitor will start charging the battery. So you don't have to park your car near a charging station. You can just get your juice within few seconds, move on and extend your journey. And the advantage is then, we talked about Tesla saying, hey, you come and charge at my charge station. But if you have a car which has a capacitor, then all you need is a 3-pin plug-in with one earth and two electrodes. So you can literally charge anywhere. You can charge in a grocery store. So I think that is where it is coming to, and that is really the bottleneck. The charging time it takes. I mean, if you look at the low-end cars, it takes 8 hours to charge, which is not practical. So you drive 200 kilometers and then you take 8 hours to drive next 200 kilometers. It's not practical, especially in 21st century. So I think capacitor is adding a lot of juice in addition to the battery, and then you don't have to really have very heavy batteries in the car. What you need is a balance of weight between capacitors and battery. And that is where it is going, Neville.
Well, as I say, we already knew that given current technology, we're almost exhausting the capability of smaller batteries, more powerful batteries, reducing the weight of batteries, etc., etc. So there needed to be another step, and maybe having a capacitor in the mix. I mean, there was always a capacitor anyway, modulating the flow, but maybe there's another sequence, and it's going to be physics. It's bound to be physics that we know. Bound to be electrical theory, physics theory that we already are in control of. And it's just going to take that, excuse the pun, that spark where somebody's going to come up with another way of doing things better. And I really look forward to it, because this is where we really start to push the envelope. We start to push boundaries. And of course, you or I, we can explain this, but we're not physicists, we're not, electronic superheroes, but there will be one of you out there. So we're going to reach out to you today and, come on board and have a discussion with lots of people in the world that want to know what's happening. They really do want to be confident that the next step is going to be a step that they can accelerate. And the only way we're going to do that is to convince them that we're on the right track. And you're the person to convince them, not us. We can help you, we can increase the audience, but you're the person to come and convince them. So come on board, have a chat with us, and let's see where we go.
Absolutely, Neville. In fact, a lot of engineers can get connected with us, and if they are doing some groundbreaking, earth-shattering R&D in this space, for example, I've heard about graphene is being used in the new age capacitors, so they can talk about it. That will actually give them a footholding in terms of generating more revenue for their company if they are actually in R&D stage right now. At the same time, there are a lot of advancement in the hydrogen fuel cell technology also, which is an alternative to a capacitor. And the third one is really futuristic, which is having a degenerative nuclear power, which powers the satellite. But that's not safe as of now. So I think the best bet for us to move ahead, powering our vehicles, also powering the telecom towers in remote location, is the capacitor technology. It is safe. It does not spoil with a number of years. It has a long shelf life, and people who are behind it can join us and talk about which stage of commercial use they are in, and we will help them promote their product in a better way. Isn't it, Neville? Absolutely. We can only push the envelope that other people are already creating. So the whole point about this discussion today is to open it up, Pandora's box. We know we're moving forward. We know we're moving forward at a very fast rate. So what we need to be doing is bringing people along at the same rate. I think technology is probably 5, if not 10 years ahead of the layman's understanding. And what we need to do is close a few of those gaps. And in some respects, raise people's expectations as to what's currently available. But we're never going to win this war on our own. So we're looking out to all of you listeners out there to come along and help us. Let's spread the right word and get this good technology out there, and being used. Absolutely, Neville. It was an interesting discussion, and we'll catch up again tomorrow on something more interesting.
Absolutely, CK. Have a great day, everybody, and we'll see you tomorrow.